Hello, all algebra students. I hope you're doing well. We are continuing in chapter 5, and this is the second day that we're going to be talking about slope-intercept form. So remember, slope-intercept form is y equals mx plus b. And today what I'd like for you to be able to do is to write equations in slope-intercept form based off of points, graphs, and to be able to graph a line from the equation as well. So first we are going to look at a graph and then pull the information out of the graph that we need in order to write the equation. So as a reminder, m is equal to slope, which is equal to rise over run, while b is equal to the y-intercept. So we are going to try to write an equation in slope-intercept form of this line right here. The first thing I'm going to do is look at the y-intercept, and the y-intercept is where the graph crosses the y-axis. So that's this point right here. So I now know that b is equal to -2. Then I'm going to try to find 2 points that are easy to read from and calculate the slope. So this is another easy point that's clearly at the intersection of the notch marks. So how do I get from this point to this point? I go up 2 and then over 1. So m is going to be 2 over 1. Now I'm going to use those values and stick them into my equation. So I have y is equal to 2 over 1 or 2. You can make it a whole number if you want. I'm just putting it over 1 so we remember the denominator. X minus 2. And there's my equation. Let's do it again. So we're going to look at the y-intercept. Remember, that's the up and down axis. So right here is my y-intercept. So b is equal to 2, and m is going to be a negative number. How am I getting from one point to the next? So I'm going to choose this one because it's easy to see. I go down 2 over 2, down 2 over 2. So that's going to be -2 over 2 or -1. I just reduced this fraction. So now I'm going to take those two values and stick them into my equation, and I get y is equal to -1x plus 2. Now you might write y is equal to -x plus 2 or -1 over 1. All of those things are acceptable. They're all saying the same thing. It's just a slightly different way of writing it. Okay. Moving on to example 2, now we're going to use a table in order to write the equation. So first we started with a graph, now we're moving on to a table. So it says, a set of data is shown in the table. Determine the values of the slope and the y-intercept, then write the equation. Okay. Don't forget that these are ordered pairs. So I can rewrite them if I need to out to the side. So this is -3, 5, 0, 3, 3, 1, and so on and so forth. That's all that this table is. It's just ordered pairs written into rows. Okay, now I need to find the slope and I need to find the y-intercept. So let's start with slope. M is equal to slope, which is equal to rise over run. And we, that looks like none. That's supposed to say run. But anyways, we learned a formula for calculating this, which is y sub 2 minus y sub 1 over x sub 2 minus x sub 1. We can pull coordinates out of this table and plug them into this equation. It does not matter which 2. You just need to choose 2 that, and keep it consistent. I'm going to choose these 2 because they're easy. So I'll come over here and I'm going to say x1, y1, x2, y2. All right, so this now becomes 1 minus 3 over 3 minus 0, which is equal to -2 over 3. So now I have my slope. This is my slope right here. Next, I need my y-intercept. Now, I want you to think about this up here on this graph real fast. The coordinate for this y-intercept is actually 0.02. Notice how the x is a 0 value. The coordinate for this one is 0.0, -2. If I had an intersection at anywhere on the y-axis, let me draw one down here for you. Anywhere on the y-axis, like if it were right here, that would be 0.04. This point right here, 0.0, -3. Notice how the x is always a 0. So in my table, I'm going to look and see if there's an x equals 0 anywhere, and that's going to tell me my y-intercept. Right here, x is 0, which means my y-intercept is 3. Now I'm able to plug everything in. So y is equal to -2/3 x plus 3, and there's my answer. Let's do that again. So it says a set of data is shown in the table. Determine the values of the slope and the y-intercept, then write the equation. So let's do the slope first. M is equal to y sub 2 minus y sub 1 over x sub 2 minus x sub 1. Just choose two coordinates. It really doesn't matter. I'm going to choose the first two. So I'm going to say this is x1, y1. This is x2, y2. And let's plug them in. So I have 8 minus 0 over -8 minus -12. Well, 8 minus 0 is easy. That's 8. I need to change this minus a negative into plus a positive. And now I have -8 plus 12, which is going to be +4. Now this does reduce, and this reduces to +2. So now I have my slope. Next, I'm looking for the y-intercept. Remember, for a y-intercept, the x equals 0. That's pretty important for you to remember. So I will box it and highlight it for you. Okay. The reason I say that is because I don't want you to go here and say, oh, the y-intercept is -12, because this is the x-intercept. We want the y-intercept, which is going to be over here, which is 24. So this guy right here is B. So now I'm at y is equal to 2x plus 24, and I have my equation. Okay, let's flip this paper over and continue working. We have one last example and then we are done. Okay, so it says, are the following statements about this graph true or false? So let's just identify some things that we know about this graph. So we know that it has a positive slope. And we know that it's representing something about games being rented and the total cost. So apparently, the more games you rent, the more the price is going to go up, which does make sense. So we're going to need to use these number values to figure out rates of change and things like that. So it says the cost increases by $20 for every 5 games. Okay. So for 5 games, and we can like make a table, so to kind of make a little more sense of it, we can say number of games and cost. So here, if I have 5 games, the cost appears like it's going to be $30. So we have 5 games, $30. Okay, now if we rent 10 games, it's going to cost us $40. If we rent 15 games, it's going to cost us $50. Okay, so I have a decent amount of information in my table and I should be able to pull from this. All right, so it says the cost increases by $20 for every 5 games. Well, here this is increasing by 5 games, but it's only increasing by $10. Notice 30 to 40 is plus $10. 40 to 50 is plus $10. So I know that this guy right here is false. That's not true. Then it says the cost increases by $10 for every 5 games. All right, well, that's what we just discovered down here in the table, so that one is going to be true. All righty. Next it says the cost increases by $1 for every 1 game. Now there are a couple strategies that you can do for this. You can take like $5, 5 games for $30 and figure out how much it is per game. So we could take like 30 divided by 5 and that would help us out. But ignore what I just said there. We wouldn't be able to do 30 divided by 5 because it's not going to be consistent for each one. I apologize. Because it starts at 20. So we're going to have to ask per five games, it's increasing by $10. So per one game, if I divide this by 5, so this is plus 5, this is plus 5. If I were to divide this 5 by 5 and this 10 by 5, I'm reducing the rate of change down here. So that would actually be false because if we go up little by little by little, if we were to only increase $1 per game, then I would only be up to $35 over here. But I'm actually up to 40. That's double that. So it's going to be $2 per game. So this one is going to be true. And there we have it. I hope that's making sense for everybody. Make sure that you bring your questions to me tomorrow and have a good night. Bye.